Okay, so let's start with the first part, which is quite easy. So once you will understand the try-catch mechanism, this will allow you to understand try-catch for also for Java, C Sharp, and other object-oriented languages. Okay, so this mechanism is present also in other languages, and you will understand what's the idea. And the syntax is the same. So the syntax that you will see today in C++ is also the same syntax in Java, C Sharp, JavaScript, and others. So it's very similar. It will have the same keywords. Okay, so again, if you get the idea of this mechanism, this is learning at least three languages during this class. You will understand how this works for C++, Java, and C Sharp. Okay, so we talked many times why sometimes it is okay to throw exceptions. And remember, the main reason is to warn others that every time they will call us by sending us a wrong value, then one way to make that clear to those is to throw an exception. So for example, here I will just focus on the try-catch mechanism. Okay, and I will just go for a function, something like this. And here, let's suppose we have a function which let's say encapsulates the division between two numbers. Okay, so division, and here I will have int a, int b, and generally we do what? We do this, return a divided by b. Again, remember that here when you have two integer operands, the division will be integer based, which means if a is 2 and b is 4, the result here will be 0, because when you divide it as integers, you don't get 0.5, you get 0. So always watch out for this. So how you do that? You should make sure that at least one operand is a float, or you do a cast here. Okay, so you, even if this is an integer, you cast it to a float. So in that way, now the division will be float based, which means you get 0.5. Okay, so we have this very simple method, and obviously here others will use the division function. Okay, so for example, let's say we have int vb1 equals 10, and maybe they read these values from the console, 20, or let's say 0, and now they will do the division. So float result equals division, and here I will have VB1, VB2. And I think it's obvious that this will do a zero-based division. Okay, and if I will run it, debug start without debugging. 1 second to, yeah, it already crashed, or no. Okay, so it's saying nothing. Let's print the output. Let's print the output. Let's see what's the result. So here I will say cout end line. The result is, and let's see the result. Okay, so build, rebuild, and debug start without debugging. And this is what I get. The result is inf. Okay, so I have an exit code 0, which means it's okay, but obviously this is not okay because we can't divide to 0. Okay, so what we learned in the previous weeks is that every time we have a function, it doesn't matter if this is a class function or a generic function, if you have input arguments, always validate. So for example, one case that we can't handle when we divide is that b is 0. So if b is 0, okay, then what do you do? And we talked. So some of you said, hey, let's return -1, or let's print a message. Cout, yeah, but we print the message before return because it will not execute. Something like this, cout end line. We can't divide to 0 and so on. And generally this can go unseen. Okay, so because if they didn't validate if VB2 is 0, they may not see this message, or they will not check the result. And -1, it's a valid result. For example, if you divide two numbers and the result is -1. So for example, you have -2 divided by 2. The output is -1. So you see, you can't check if -1 is correct or not, because -1 can be correct if you have -2 divided by 2. So we said that we don't do this in this kind of cases, and we throw an exception. So here I will say throw, and here I will say exception, and here I will say B is 0. Is 0. Okay, so what will happen now if I will run this build rebuild is that the program will crash. Okay, so start without debugging, and now it's finally crashing. Okay, so you see this, it's crashing, and the reason it's our exception. Okay, so we generated this. Okay, so at this point, they understand that they need to validate. So if they will test their code and they will see that sometimes it's crashing, now we hope that our colleagues will understand that now they need to do this. If VB2 different than 0, then they will try to divide. Okay, so in this case, we force them to also validate. So this is the idea. That's why we throw this exception, to make them write this. Okay, now here, all this stuff is clear. Okay, so it's a very simple program. It's easy to understand. But sometimes you work with libraries. You are using system libraries or libraries written by other developers, and it will not be clear what exceptions you are throwing or when you are throwing the exception. So if we don't do this, okay, so I will write this again. If we don't do this, can we have a chance to fix the program? Can we have a chance to say, hey, I'm sorry, I didn't check this one, but let me try it again? And for this one, they introduced this mechanism, and you have it here. It's also described in the course presentation. So the exception handling, and there are quite a significant number of slides allocated to this. And this mechanism works like this. Now in C++, and this is like a disclaimer, you can't catch system errors, unfortunately. But in C# and Java, because you have a virtual machine, you will be able to do that. So you can actually catch all the exceptions of your program. It's like your program will never crash, or when it will crash, no one will see it because you might have a solution to that. But in C++, this doesn't work as you will want to work, because it will work only for the exceptions that we throw, because we don't have a Java virtual machine and the compiler is not able to use a catch for a system exception. Okay, so how this works? So you have this try block, and if you translate this to try, means try to do something, and here we talk about something that may generate an exception. So in a try block, generally we do something that there is a probability that it will crash. And after that, so after the try block, you have these functions. So these are functions, and they are called catch. Why? Because if here in the try block someone will throw an exception, then one of these functions will catch it, and you don't see the pop-up anymore. So the execution of your code will continue here, okay, in this block. And here, because there could be many exceptions that a function can throw, or a class, here you can write as many catch functions as you need, And here you should pass different arguments, different input arguments. And generally a catch will receive only one input argument. So let me show you how this works. So here we know that this is dangerous, okay, to do the division. And we want to be prepared if the program will crash, again, if we try to do a division by 0. So I will say this, try. Okay, so I'm trying to do this. I have a feeling that, or there is a probability that this function will throw an exception if VB2 is 0. And it's clear that is 0, but we don't check. And that's actually the issue. Okay, and now I will say, hey, if this source code, any instruction here in the try block will throw an exception, I will catch it here, exception E, and here I might do something, and I will say cout end line, sorry, I didn't check VB2. Okay, and here E, in order to show the message, remember some of you asked me this, how can we show the message? Here you have cout end line, and here I will say error, and here I will say E what. Okay, and this is a function, and this will return the message which has been associated with this exception. So if I will run this program, okay, again we will try to do a division by 0, and here we'll throw this exception. So build rebuild. Okay, debug start without debugging. And earlier the program crashed, but now is not crashing, and we see this. Sorry, I didn't check VB2, error, B is 0. Okay, so you see, in this way, we throw the exception, but now we have a way to actually catch it and do something here. So now we are prepared for that. And obviously here we do something to fix it. Okay, either we ask VB2 again or whatever. So this is the way you can catch exceptions. Now, let's suppose that in the division, we have multiple exceptions. So let's say this is a very particular method. It's very sensitive, and it can't do division by 0. And also, let's suppose, I don't know why, but let's imagine that we have this extra condition. So if A is bigger than 1000, again, we want to throw an exception. So here I want to say throw exception A is too big. Let's suppose, I don't know, this works on a microcontroller and we can't handle values bigger than 1000. So in this case, the function, the division, may throw two exceptions, one for B0 and one if A is too big. So what's the issue? The issue is that, you see, if here we do this, VB1, or yeah, I will leave this. Let's do this again. So if I copy paste this sequence again, let me show you. Okay. If here I will do this, VB2 equals 10, so it's not 0 anymore, but VB1 is, I don't know, 100,000. Okay. Then if I will run this, build, rebuild, and debug start without debugging, debug start without debugging, and you run it, we will see this. Sorry, I didn't check VB2, error, A is too big. So you see, now the second exception has been generated, the one with the A is too big. And here, I still see my initial message, because when we initially implemented this program, the only reason for division to throw an exception was that VB2 was 0. But you see, now the function has evolved, and now it may throw another exception also here for A bigger than 1000. So what's the problem? The problem is that here, how can we know what's the reason? So do we know that when we reach this catch, the reason is that VB2 is 0, or because VB1 it's greater than 1000? Now you may say, yeah, you see the message, agree with that. So here I can say an error, sorry, a generic message, which can work for both cases. And here I will see the specific message, which is created here. But can I determine here in the catch, which actually is the exception case? Is the 0 or greater than 1000? So when you have this situation, when a function may throw different, will throw exceptions at different moments because of different things that you check here, you can actually make a difference. So here, instead of using this generic exception, this is the class which defines exceptions in C++, and it will be the same class in C# and Java, but there is written with caps, with capital E. When you have this case, based on what we have discussed on Monday, on Tuesday, we can create our own exceptions. And then you can actually handle this very, very smart. You can actually know the reason when you catch the exception. You don't need to check strings. So I will define here my own class called division by 0 exception. Okay. And this class will extend. So I'm not reinventing the wheel. I'm just designing. I will reuse it. And now this class will extend the classic exception. So now we have our own exception called division by 0. Now, if you want to add messages to the division by 0 exception, then you need to define a constructor. Okay. Here you need to ask for a string, for example, message. Okay. And here, in order to initialize this message, because if you write here this, there is nothing here. So the message attribute is protected. It's not protected. It's private here in the exception class. So we can't access it directly. But based on what we have discussed Tuesday, I can call here my parent constructor. And here I will say exception of message. Okay. So right now I'm passing the exception, the message to the exception class constructor, which is my parent, because I'm extending it. The issue here is that generally the exception here handles the message as a char asterisk. And remember, if you want to convert a string to a char asterisk, you have here this function, cstring. Okay, and now you pass the string as a char array, as a dynamic char array. So this is how you convert. I think I showed you that already. But if you forgot, this is the way we do it. Okay, so in this way, I have my own exception. Now let's do another one. Class value too big exception. And here I will say this extends exception again. And I will use the same approach. I will define a constructor here, and I will here I can pass the message as a char array. So I will not be forced to convert it. So here you see the alternative. Okay, here I will say exception. So I'm calling the base class constructor, and I'm saying, hey, take this message from me and initialize it. So right now I can send that message to that constructor. Okay, so right now I have these two particular exceptions. So what's their value? If I will rewrite division, so if I go here and say, let's say division version 2, instead of throwing exceptions, so in the end, you will never know what's the reason. Maybe you will know it by seeing the message, but we want to know the reason without actually checking the message. Here I will say throw division by 0 exception. And here I will say throw value too big exception. Okay. Okay, and it's saying is inaccessible. Yeah, because I forgot to define a constructor public. Okay, so what's the difference between division and division version 2? You see, it's the same logic, but the only thing we did different is that instead of throwing generic exceptions, now we are throwing particular exceptions. So how that would be helpful to us? So let's copy this again. And here, I will again copy this part. And here I will say VB2, blah, blah, blah. And here I will say division version 2 or VB1, VB2, the result is. And here, instead of catching the exception, now I have the power to catch either division by 0 or value too big. So you see, right now you have the power to know why the function crashed. So here, instead of using a generic exception, I will say, hey, if I will reach this catch because this function throw the division by 0 exception, it's clear, right, why we are here. Sorry, I didn't check VB2 and error. And now I can write a separate catch for value too big exception. Okay, exception. And now, obviously, the message will be different. I didn't check VB1 because it's bigger than 1000, and here the error. So if I will run this, okay, debug start without debugging, and you see the screen right now. You see the message is I didn't check VB1. A is too big. So because we throw the value too big exception, and if you change, for example, VB2 now, VB1 becomes 0 because this is the first thing that we will check. Now you will see the other message. Okay, debug start without debugging. Okay, now you see the result is 0. And why the result is 0? Let me check. So VB1 it's yeah, it's true. VB1 is 0, 0 divided by 10. So what I wanted to do is actually this. Okay. Debug start without debugging. 1 second. And now you have this. I didn't check VB2, B0. So you see, this is the power of try catch and creating your own exceptions. Because right now, when you catch it, you know for sure what's the reason. Here, when you catch the generic exception, any reason from here could be true, either this one or this one. So that's why when you work with exceptions, always define your own exceptions, because you see how easy it is. Once we know inheritance, we just define them, and now you throw them and you catch them. Now, if this story will go on forever, for example, this function will throw maybe other exceptions, then there is a catch which catches everything. And this is this catch here. Sorry. Okay, this catch with the 3 dots, which is a function with variable length input arguments. So if I will write this here at the end, any other exception which is thrown by either any instructions here will be catched by this one. And obviously, when you reach this point, it's clear that you had the problem, but you have no clue what was that, because this catch will catch everything. So we have a problem, but you don't know for sure what's the reason. Okay, so this catch is the catch which will catch everything. And because here the compiler, when an exception is thrown here, the compiler is checking the catch functions from top to bottom. If you try to write this as the first instruction here, as the first catch, you get a compiler error saying handler is masked by default handler, which means if you write this as the first catch after the try block, it doesn't matter. This will always execute. and a catch function will execute only once. Okay, and if you write this, you make obsolete all this other catch. You will never reach them. So if you write this before other catch functions, unfortunately, fortunately, you have the compiler which will alert you that that's not okay. Okay, so let me show you how I will reach this point. So for example, here I have, you see the division is done correctly. So you will have 10 divided by 5, no issue here. But for example, here, I don't know, let's throw exception error. Okay, so if I will run this program, then this will execute. When it will reach this line, it will interrupt. So the throw function will interrupt the try block. And then the execution will go where? This catch is only for division by 0 exceptions. This catch is only for value to big exception. And this catch is for everything. So if we run this program, we will see we have a problem. So build, rebuild. Okay, debug start without debugging. Okay, and you see we have a problem. The function, the division worked, the result is 2, but we have a problem, okay, because of that throw. So
sorry, I joined a little later. Could you show us again, I mean, where did you define these exceptions, like up
here,
there?
Yeah.
Oh, okay, okay.
So you see I have defined my own class, and in order to make this class to be able to be used inside the try-catch mechanism, I need to make it an exception. And we have in the system, in the C++ libraries, you have a class called exception, which we have used before. So how do I make a class to become similar to the exception? We inherit it, right? We just extend it. And now this is like an alias, which is defined by us. It's a different class, but it will behave like an exception. So right now I can throw it, okay? Now I wrote this constructor because sometimes you put messages in the exceptions, right?
I knew that there were something like, I don't know if it's in C++, I know that it's in C#.
Yeah, it's the same.
Yeah, some created for the situations created by default by the compiler.
Exactly. So in this case, if you still want to put messages in your exceptions, and some of you ask me, hey, how do you get that message? In this way, with what? So when you cache the exception, you ask what, and you get the message. Now, for your classes, by default, the message attribute inside the exception is private. You can't access it. So if you try to write here this something, this is what you can access from exception. So you can't access the message. So in order to initialize the message, you need to define a constructor for your division by 0 exception, but this is not mandatory. You can also have a default constructor here. So in that way, you just define exceptions and you don't set any message. But if you want to set the message, then you ask for a string or a const char asterisk, okay? And in order to pass this value to your parent, like I showed you on Tuesday, you call the exception constructor, which receives this message. And then that constructor will set this message, okay? Because it's private. So we are using the base class, the parent class constructor in order to pass this message. So when you create a value to big exception, this message is received by our exception and it's passed to the exception constructor. So in that way, you set it. I don't know why they choose to make private the attribute, but this is it. So the only way to initialize that attribute, which you inherit, we talked about this on Tuesday, but we can't access it directly because it's private. So we have it, but we can't access it. So this is a workaround. Okay, you call the exception constructor and you pass the message that you receive here. Okay, so what will be the conclusion? if we validate and we throw exceptions, because you see how easy it is to define your own exceptions. So it's quite cheap. You just define these classes and you can define as many classes as you want. Okay. The recommendation will be to define your own exceptions, because this makes also the code much more clear. So when a colleague will read your source code, it will see this division by zero exception. It will see this, and it will be obvious when you catch them in which case you are. Okay, so why are you here? Because maybe this function throw a value too big exception, which you see it's much more easier to read the source code. And also it will give you the power to have different solutions for different cases, because otherwise if you just throw generic exceptions here and here, you will have a catch which will catch both, but how do you know what's the reason? Is the B 0 or A greater than 1000? Okay, so that's why always define your own exceptions. It's easy, and use them, because you will have much more flexibility here when you write the catch. And if you want to be, let's say, bulletproof, so here you call a lot of functions, and I don't know, you know that division will throw these two exceptions, but maybe here you have another method which will throw a generic exception, and you want to catch that, use this generic catch. Okay, so this one will catch any other exception which is thrown here. And the last thing that I want to show you about try is that the try block will execute line by line until it will throw an exception. For example, you have seen if we throw an exception here, so if we pass to division version 2, we pass 0, the division version 2 will crash, will throw an exception, and we will not see the result is. Okay, so let me run it again. Okay, and you will see that, you see, I didn't check VB2, I don't see the result is, which means, and this is important to remember, that the try block will execute line by line until an instruction has generated an exception, and at that point, the try block is terminated. Okay, so if this will throw an exception, these two lines will not execute. And now the execution will continue in a catch, which has a solution for that exception that was thrown by division version 2.
But
okay,
this catch is like else's in the if else.
Yeah, it's like a switch.
Yeah, it's like a switch. Yeah,
exactly.
So, and in any of the cases, it will enter another type, like if the division by the okay.
And that's why you see it's important to have your own exceptions, because if you use the generic exception, you can't have multiple catch functions, because you'll have only one, right, which will catch an exception. But we have many reasons for different exceptions, so that's why I use custom exceptions. Okay, so remember the try block is stopped on that line which throws an exception, and now the execution will jump to any catch which will offer a solution, and only one catch block will execute. Okay, and this is the way this works in Java and C#. And in Java and C#, because you have a virtual machine, if here you do a system exception, let me show you, like index out of bounds or something. So let's write something here. Yeah, let's try to delete a static array. Okay, so I will have something like int values of 5. Yeah, let's try to, let's see, index out of bounds 500 equals 90. Obviously there is, okay, we have only 5 elements in here. We try to access that one. Let's see what will happen. So debug start without debugging. Okay, the program crashed, and you see exited with code. I don't see the pop-up. Sometimes we see it, but you see the exit code, and it crashed. Okay, now you might say, yeah, but we were in a try block, right? We were safe. We were here. So when this crashes, why this is not executed? Because in C++, the system, you don't have a virtual machine, the compiler is not able, when it's compiling this, to say, hey, if here you do a problem, go here. It's not able to do that. And in C# and Java, because you have a virtual machine, a big brother, and the big brother will say, you did something wrong here. Let's see, you are in a try block. I think this will give you a solution, but not in C++. So you see in C++, this works only for stuff that we throw. Okay. Unfortunately, it doesn't work for system exceptions when you do something like this. Okay, so this will work in the next semester. So in the next semester, if you do everything in a try and you have a catch, you catch everything. So it's like no one will see that your app crashed. Okay, but in C++,
so we have to throw the exception in order to
exactly to catch it. Yeah.
Mm-hmm.
This is like playing soccer on your own. So you pass the ball and you shoot. Okay, it's like you play alone. In Java and C#, as I said, because you have a virtual machine, which is like a team monitoring you. At runtime, if your program does something like this, the virtual machine will say, hey, stop, let me help you. Okay, and it will redirect the execution to a specific catch, but not here. In C++, there is no one monitoring you. And if you get a system exception, that's it, you are interrupted.
But in order to have the program enter some of the catches, we have to do this throw exception without any name.
Yeah.
Okay.
So you need to throw them. So in C++, this is like a way to talk with your colleagues. You see, I showed you that if they will call your functions and they don't validate, you need to give them a very strong response. That's not okay. So we throw exceptions. And now if they know that, now they have a way to be prepared. So if they don't validate and they call us with wrong values, now they have the power to catch our responses. Okay, so now they have a way to find another way to continue the execution, because otherwise the app will crash.
But why is it like after the throw? Why is it after the division, like after 2 lines after the division, and not exactly
this one here?
After? Yeah, exactly.
No, here I was just showing you that if here you don't throw an exception, you see I have 5 and 10. And if you go to division version 2, there is no reason to throw an exception. So, and here I was showing you that if this function executes normally, you will see the result is. And here I wanted to show you that if another line here or another function, we can hide this in a function, for example, will throw a generic exception, this catch will catch it. Because division version 2 throws either division by 0 and value too big, and this catch or this one will execute. But if you have another reason here, for example, a function, void do something wrong. Okay, and here you throw an exception, exception. Okay, then, or you throw it directly, but generally it will happen like this because you call a function and that function will do something. Then the try block will stop here. So for example, if I write here another message, we will not see this one, the end of the try block. Okay, and everything else up to this point will execute. So we will see the result is 2, 10 divided by 5. And after that, we will see this. So build, rebuild, debug, start without debugging. Because in a try block, you can do complex stuff. You can have your entire program there. You see, the result is 2. And now we have a problem. So why? Because this has been executed. Here we had no reason to throw any of these 2 exceptions. Okay, this has been executed. And now when we call do something wrong, this is throwing an exception, okay, which will interrupt the try block. So we will not see this line. And now the execution will go here. And this catch will catch any exception. Obviously, any exception different than these two, because if any instruction here will throw a division by 0 or a value too big, then either of one of these two catches will execute. So you will not reach this one. But for any other exception, you will continue here. Okay, so that's why I was throwing here an exception, just to show you that if that will happen for another reason, you have another function here, whatever, now this catch will solve it. Okay, so this is the try catch mechanism. Okay, and generally this is a pattern you will see next semester. So in Java, in C#, you will have all these try catch blocks, and you will use them every day. Okay, so this pattern is used. So every time you do something which is sensitive, which might crash, you do it in a try block, and after that you find here solutions to whatever. And sometimes this is very valuable. This is a trivial example, but let's imagine here you connect to a database. So this is something you can't control. For example, your network is down and you can't connect to the database. So what do? It will crash with the connection exception, and you go here and, I don't know, you ask the user to check the network, or you do a temporary backup because you don't want to shut down the application and lose all the data right before you wanted to save it. Okay, so generally we use the try catch for handling special cases when something might happen. We don't want to be there, but it will happen, and we want to have a backup plan, and the backup plan will be here. Okay, so this is the try catch mechanism. Okay, and this is how you define your own exceptions. It's quite easy. You just define. If you ask, can you define here attributes? Yes, I don't know. If you want to do this logging mechanism and log other information, you can add attributes here, like I don't know, the name of the software, the line number, the name of the library, whatever. So you can add here other attributes which will be added to the ones that you inherit from exception. But generally, this will do the work. Okay, so you can define your own exceptions easily. Okay, and you have all this stuff here. Okay, all the things that I tell you, they are all summarized here. Remember, you have this PowerPoint. And here I'm doing a summary of all the important stuff that I tell you. So just go from time to time to the PowerPoint presentation. So that being said, let's switch to files. Okay, and for files, again, I will help you remember stuff that you already know from C. Because in C++, we play with files in a very similar way. The only thing that they did was to give us classes. Remember in C, so this is for files. In C, you had this file structure, remember? And here you had a pointer to the file. And this is the way you work with files in C. And this was like an article, you had a pointer to it. And after that, you had the fopen, if you remember. And here you pass the name of the file, for example, report.txt. And here you had all those read binary, read, write, plus, blah, 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 and so on. Implicitly, all the files were text, remember, okay? And if you want to define a binary file, then you use the B word, the B, write, read, write, B plus, or whatever. So this was the way in C. Now, so let's say the C approach. Now, in C++, because we talked about object-oriented languages, now they replace this stuff with objects. And they are giving us classes which they behave like streams. Remember, we talked about streams, scene, cout, output stream, input stream. So they have defined a file stream So this is the generic class which you can use to handle any file. So this is the equivalent of this file here. So this will be a file. Or if you want to be specialized, incomplete type. Okay, so I need to pass, I think, some data here. Yeah, because it's an object. Okay, and if you want to be specialized, if you want to use files only for reading or only for writing, you have, as we talked about input stream and output stream, you have OF stream. And this is when you want to use a file to write to it. So O stands for output. Okay, so I don't know, report. Okay, and if you just want to read, only to read from a file, you have input file stream, EF stream. Okay, input file. Okay, so in this way you can distinguish between them. So let's say this is an output file, Okay, and the generic, which is the equivalent of the file structure in C, is the F stream. Now, if you ask me, generally I prefer to use the two specialized classes, because in that way it's let's say less dangerous to do mistakes. When you open a file for output, it's clear you can just write to it, and you can, when you open a file for input, you just read from it. Okay, so generally I prefer to use either of these two depending on what I want to do. And this is for, I don't know, for generic cases when you read and write from the same file, but watch out when you do that. Now, how do we open the files? So here, this is very similar to...
But wasn't in C++ some kind of operator if you define some operators for which you read and write?
No, we can use the input stream and the output stream operator to play also with files, and I'll show you that. Because files, you see, it's a stream. So what's the difference between OS stream, which is cout, and OF stream? This is a stream to a file. OS stream was a stream to the buffer from memory. So we can actually use the output stream operator to actually write something at the console and also into a file. Okay, so let's do that. So how do you open a file? It will have a similar like this. And remember, this is an object. This is an object. So it has a constructor. So we can pass here the name of the file. So OF stream output file. And here I will say report.txt. Okay. And here we need to pass. And when you have this strange error with incomplete type, the error, again, it's very misleading, is because here you need to include fstream. Okay, so when you play with files in C++, include the fstream library. Okay, because that's the library where fstream, ofstream, ifstream are defined. Okay, so here, instead of using the these strings, which were quite difficult to memorize, I remember when I learned how to play with files in C, I always had issues here to remember what was the correct combination. So here they replace this string with actually with some numbers which are combined together using the bitwise OR, not the logic OR. And this looks like this: iOS. And you want to open implicitly all the files are text, remember. Okay, so you don't have here text because by default all the files are text. And here, when you open the file for writing, I want to open it for out, right? So I open it for writing it to it. And again, here, if you want to concatenate multiple stuff, for example, we want to concatenate. Remember, when you open a file for writing, by default, it will do a trunk. It will delete the content and you write from the beginning. So you lose the previous content. So if you want to do append, here you say append. Okay. So in this way, I will open a file, report.txt. Implicitly, it's a text file. Now, if I want to open a binary file, let's say output binary file, Okay, let's say in this case, I will say my data dot whatever bin. It doesn't matter. The extension is just something you choose. So again, I'm choosing it to open it in out mode. And I don't want to do append, for example, or if you want, you can combine that. But here it's mandatory to say binary. Okay, so for binary files, it's important to write the iOS binary. And this is like B here in C, if you remember, you had the B from binary. Okay, so in this way, I open this file. Now, if you want to open a file for reading, for example, we will write something into this report, and after that, I want to read from it. So let's open it again, report.txt. And here I want to open it in input mode. Okay, now there is no append or truncate when you open a file for reading. You just open it, you will always be at the beginning, and you just start reading it. Okay, but again, if you want to open my data bin, then you need the binary again here. Okay, it's not this case because here I want to open that file as a text file. Okay, so this is the way you can create a file. You see, this is the constructor, and here you pass all these values. Watch out here. So this is not the logic OR, which generally returns true or false. This is the bitwise OR, and here this is a number. Okay, you see it's 2. If you hover the mouse, it's 2, and this is 8. And they are actually doing OR at binary level, and they combine the bits. So here they generate a mask, and if several bits are 1 there in that mask, the constructor knows what it needs to do. So watch out here. Okay, this is the bitwise, the bit level operator. Okay. So another way to open a file, for example, you just create it here. So OFStream, let's say, this is another way, OFStream report file. Okay, and after that you say report file open, and now you pass the data. Okay, so this is an alternative. So here you say report2.txt, and I want to open it in iOS out. Sorry. Okay, so now I will open the file again. Okay, now because these are objects, okay, it means they are smarter than the file PF. Remember how you checked in C if you succeeded in opening the file? You were checking the PF pointer after fopen, and if the PF pointer was null, it meant the file is not there, which means you don't have a report text file. So how do we check this here? If output file, and here you have different methods, and you see you have is open. So this is the way you can actually check if this file is there and you were able to open it. Now, when you open a file for writing, remember, and this is again like in C, if the file is not there, it will create it. Okay, so right now, if I will run this program, it will create a report text file in my project. It will also create a mydata.bin file in the project. And here, because I don't have, I already have it, it will open it. But if I try to open a file which is not present, then is open, it's very valuable. Let me show you. So for example, let's say input file, I will say report, students report. Okay. And here I will say cout end line. The file has been created. So this is the output file. The file has been created. We can use it. Okay. But if I check this for the input file for this one, so if input file is open, let's say, is not okay, it means cout end line, let's take the name, is not present, is missing. Okay, so in this way you can check if the file, especially when you try to read from a file and you expect to have that file in your project or somewhere, this is the way you can actually check if you were able to open it, the file. So build, rebuild. Okay, I have an error here, 1 second. Fopen, this is the, yeah, it's not safe, so I will comment the C part. That was just to give you a quick reminder. And here I want to output file. Let's also put the file name here to know which one is ready to be used. So rebuild, and now I'll do debug, start without debugging, and you will see this. The report text file has been created. We can use it. The student's report text is missing. Okay. Now, where are those files created? So when you try to play with files by their name, remember they are always relative here. Okay. They are relative to your project. So when you say report2.txt, the file will be here in course 12. And again, this one and this one. If you want to open a file at a different location, you need to provide the path. For example, the school projects, whatever. Okay, so then it will try to, and you need to escape these characters. Then you need to provide the full path. But if you don't provide the full path, it will search for the file in your project. So right now, I should have a report text and the my data bin files inside the project. And remember, in Visual Studio, if you want to open the folder of your project, that's very easy. You just right click here and you have this, you see this option, open folder in File Explorer. Okay, and now here is where our files will be. You see it, report to my data bin. Okay, so I have all these files, but I don't see the students report because that file is open only for reading, so we should have it. So if I go back to the source code here, let's suppose the students report is a file that I should receive from someone else. So here I will say else. Okay, and here, if I will go back, so the students report text is available. Okay, in order to see this message, we need to go here and add that source file, text file, or you can go into the Windows Explorer and you create it. So let's do that. Okay, just got the name. I will go here and say right click new text document. Always check if you see the extension, right? Because you don't want to name your file .text, and after that you are wondering why you can't open the file. Okay, always see the extensions. And you have the option here, view, options, view, and you want to see to uncheck this option. Okay, because otherwise when you create a text file, you will be tempted to write .text, but it has already a .text extension. So your file will actually be students report .text. And in your source code, you try to open it with a single .text and it will say is not available. Okay, so always check your extensions. So here, let's write something. So let's say this is the, this file contains the names of Alice, of all our students, Bob, Vader. Okay, so I have this file, and now if I will run the program, now I should see also this one, start without debugging. So how do we read and write? Okay, so this is the question. Now we know how to open files. How do we read and write from those files? Okay, you see the students report is available because I just created it, so it's there. So let's start with text files, okay, because they are easier, and after that we finish with binary files. So let's see text files. writing. Okay, so how do we write into a text file? Now, remember, files in C++ are streams, and we know how to play with streams. This is a stream. This is an output stream, and using this output stream operator, we were able to write into this standard console stream. So if a file is a stream, and this is again a stream, and we have used this operator, why not using the same operator to write into a text file? So we have this report. So let's say output file. Okay, and here I will say, this is my report. Okay, and if you want to pass to the next line, you need to again use the end line. So output file, end line, I don't know, number of students equals 10, whatever, and so on. And I will just write this, okay? Let's say John, and so on. Now, if I will run this, and this is true, so I can use this operator to write into a text file as to write to the console, it means that the output file, the report text, should have these 3 lines. And remember, this is append, which means if we run this application many times, it will just add these lines again and again. So by default here, if you don't want to do that, it's trunc. So trunc will delete the previous content, and you have a new file each time. Okay, so now regarding writing into text files, if you use them for your project or for other stuff, you will see that sometimes it's not, you run the application, but the file content is not complete, is missing something. And this is because they optimize the way they work with files, especially with the hard drive, which is slow. So sometimes they just keep this data into a buffer, into a temporary buffer, and they will discard those lines, I don't know, at the end, but sometimes it's not happening. So a thing that you should always do, just to be sure that the content is written into the file, is always close your file. Okay, so when you say, hey, I just finished working with that file, always close it, because when you do this, it will force the system to discard this into the file. Okay, so always close your files. So let's see, debug, start without debugging. Now on the screen, we will not see anything because we don't do anything on the screen. Okay, so I still see this, but if we go to the project folder and we check the report text, you see it's not 0 anymore. And if I open it, here it is. Okay, this is my report, number of students, John. So if I will run this project again, because I have append, it will append again these lines there. Now, sometimes append it's okay if you have something like a logging report or something that you just want to add. But when you generate a report like this, yeah, append is not okay because you want a new report each time, right? So you need to think when that will suit you, if you want append or trunc. Okay, so I just run it again. So if I go back to the folder explorer here, now, because I have append, you see it's just adding this again and again. Now, for this example, append is not the let's say the best solution, but I wanted to show you how you do append. So in this way, you write into text files, and you can write anything. Now, remember, we have we can overload the output stream operator for classes, right? So if I have here a very small class, just to show you, the same operator can work with the console and also with the file. So I will just do this very simple class student. Okay, and here I will say string name. Okay, a constructor just to initialize the student. String name. Okay, name of name. Okay, and here let's overload the output stream operator. So void operator I don't want to use it as in a cascade. So that's why I'm returning void OS stream reference. Okay. Here we name it console, but here I can name it out because out now could be a file or the console. And here I want the student. Okay, student reference student. So here I will just write out and line the name of the student is student dot name. Now name is private, and I will just allow this function to access private. So friend. Okay, or otherwise I can use the get. So now I have this class student with the output stream operator overloaded. So remember, this is a stream. A file in C++ is again a stream. So let's see if this operator works also with files. So if I go back here, okay, and we create a student John. Okay, John. Now, if I will use the cout, we know it's working. Okay, so here we will see on the screen the name of the student is John, but you can also use it with the output file, John. So right now, the same operator will return that the name of the student is John here to the console and here to the output file stream because they are both streams. So build, rebuild, debug, start without debugging. So I should see the name of the student on the screen. So I have the name of the student is John. And if I check the file, I should have that also there. Okay, let's see. So report, and here it is. The name of the student is John. Okay, so here I'm in the report. So if you have the output stream operator overloaded for your class, you can use the same operator to print your objects data into text files. Okay, so this works only for text files. The console, it's working with text files. Okay, so you can use the same operator if you have this one. Okay, so this is the way you write into text files. So here, the only thing that you need to figure it out is what do you want to write? And that's it. So you just write it. And don't forget to close the file. Now, the problem with text files is how do you read them? Especially when you want to load that data into memory. Okay, so for example, I have this text file, okay, the report. And you see here, there are a lot of texts which sounds okay for humans. So we can read this easily. We can interpret it easily. But how difficult will be for a machine, for a software to interpret this? Because here you see the problem with text is that you need to parse them. And this is what you need to do for the project. You need to parse some strings. So parsing strings is difficult when you don't have rules, because here, yeah, you may say the number of students equals. So you take this line, you stop here after this equals, you know there is a space here, and after that you have some digits which are a number. So even for this simple line, it's not so simple to actually extract the number of students, to extract this number. Okay, so reading from text files, if you want to interpret that data, if you want to load that data into memory, then writing reports like this, it will not be easy for you to do it in reverse, to read this. So you need to think differently when you play with text files from which you want to read data. Now, if I just want to read this file, or I don't know, maybe this file here, the students reports, which now is open. So if you just want to read it, John, Alice, Bob, Vader, that's easy. But remember, the question is, how do you extract the data? So let's reading. So I have the this file here. Yeah, let's take this one here. put it here. And I want to read the students' names. So cout end line, the students' names are. So now we want to read. And we know that in that file, we have names like this, okay? John, Alice, Bob. So each line has a name, which is great. So I will say this, while input file, and you have this end of file. So while we didn't reach the end of file, so while not input file, end of file, again, you see how it's much more easier in C++ to check if you reach the end of file, because it will tell you. Then I will say here, string student name. We read into this input file student name, and now we print it. Cout end line, student name is, and here you have student name. Okay, and don't forget to close the file. Always close your files. Input file, close after you finish working with that file. So right now, if I will run this program, I should see the names of the students from that file on the screen. So let's see. Debug, start without debugging. Okay, let me show you the screen. And here they are. Student name is John, student name is Alice, student name is Bob, student name is Vader. Okay, so if you have a text file and each value is on a single line, you see it's very easy to read it. So if you have data for a class, for example, you store your objects data into text files. For example, I have this student class here, and I have name, and here I can have also age. Okay, and maybe here I can have, I don't know, the faculty. And maybe you have also the grades, something like this, grades, and in number of grades. Now, how do we need to write the text file so it will be easy for us to actually read the student data from that text file, so it will be easy for us to map the name, to map the age, to map the faculty, and to map the grades and the number of grades. So in this case, always try to think as a machine and always try to follow this very basic rule, because otherwise you will spend a lot of time parsing texts, and that will eat up a lot of time and you will do mistakes. So for example, I want to read this student data. Okay, so I have this student and I want to build the student back from the text file and to build it back into memory. So here let's define the constructor name, age, string faculty. Okay, and here let's say we receive the grades array and int number of grades. Okay, so let's use the initialization list, it will go faster. So here I have name of name. Yeah, sorry, I didn't wrote this with caps, but I hope that now you don't have this issue here. Faculty. Okay, and yeah, for grades we don't do this for grades, but I can do it for number of grades. So for grades, I need to, we know the drill. This grades equals new int of number of grades. So don't do the shallow copy. And here you have the for int I at 0, I less than number of grades, I plus plus. And here you have this grades at index I equals with grades at index I. Okay, so now we can build the student if we have all its data. So let's see how we can actually get this data from a text file. So when you have text files, which you use them to load data, okay, so it's not a report for the secretary, okay, it's not something that a human can easily read and say, hey, that's the list of the students which have a scholarship. So you use text files to store data, okay, to store data and to load the data. So when you are in that case, you go back here. So I will be here, and let's say I will say new text file, and here I will say student data. Okay, so I have a new student data text file, and if you write it like this, the name of the student is John, and after that you say his age is 21. Now, if I will ask you to do this at the exam, so I will give you this file and I will say to you, hey, write a C++ program which will extract the data from here, I don't think you will finish in 1 hour or 2. You will spend a lot of time trying to figure it out, where is the data and so on. So when you use text files for storing data as an alternative to binary files, you need to be smarter, okay? Don't create something that it's easy readable by a human, because you need to read this from a software, from a machine. So the basic rule here is to use a pattern. Now, there are many patterns, and if you play with Excel, you know that a way to store table data, it's to use CSVs, comma separated values. So a text file with the CSV extension means that you have the value separated with comma or any other symbol, but CSV stands for comma separated value. So here you will write it like here, John 23, and after that the faculty, CA, and the grades. You need to know how many grades, 4, and after that the grades 10, 10, 9, 8. And this is a CSV. And if you open this in Excel, it will separate the values, and you will know that the first one is the name and the second is the age, the faculty, and after that you have the number of grades. Now, even this one, for us at this level to interpret it, it's still, let's say, challenging, because you need to use str, and other functions, if you remember them from C, to split this by comma. So how can we write this much more easily? Always follow this basic rule. And the golden rule of text files, if you want to load data, is this one: 1 line, 1 value. So here the separator for you will be enter, 1 line, 1 value. So you know that the first line is the name, the second line is the age, the third line is the faculty, and after that, because a student might have 3 grades, another student might have 10 grades, you need to know how many grades there are, because you need to know how many lines you need to read from that text file. So here, always, every time you have something which has a variable length, always write that number. It will help you when you read the data. So here I will say 3, because maybe John has 3 grades. And now the grades, again, 1 value, 1 line, 9, 9. Now, if you have here multiple students, use the same pattern. Remember, software is deterministic. Software likes patterns. Always use the same rule, which means after you wrote the grades for John, now you can continue with the next student, Alice. Alice has, I don't know, 22 years and so on. Alice is from management, and now Alice has 5 grades. For example, I don't know, 10, 10, 10, 9, and 9. And after that, you want another student, Bob. Okay, Bob, age 23, faculty, again, cybernetics. And maybe Bob doesn't have any grades. It's first year, first semester, it doesn't have any grades. So how do you write this? Always follow the same rule, okay? Don't do exceptions, because an exception in software means an if. And once you start writing ifs, that will be a path to a very complex program. And in the end, you will do mistakes. It will be difficult. So don't treat exceptions differently. So what's the pattern here? The number of grades and the grades. So how do you say Bob doesn't have grades? 0. And after that, you continue with the other student, Vader. And now Vader has 23, CM, maybe 2 grades, and here are Vader grades, and so on. Okay, so use this approach. Now, if you send this to the secretary or to someone who needs a report, yeah, it will be difficult for that person to understand what's here. But remember, here we are using text files to store data and to load the data. Okay, so you see there are 2 different perspectives. The human perspective, when the report file should be very, I don't know, pretty, with text and so on, and the machine perspective, when the file should be very simple because you want to write simple code to read this. Okay, so how do we read this? Okay, so if I go back, so this is called student data, and you see I can create students. Let's read the first student from there. So reading the student data. So let's create another input file, student data. Okay, student data dot text. I want to open the file for input, for reading in. Do I have another student data? What? Ah, sorry, it's not input file, ifstream, sorry. Okay. Now, always check if the file has been opened. Okay, so if student data is open, now we can read from it. Else, write something here. And when you do your project or at the exam or I don't know, every time you play with files in school, okay, so in school, don't do this in real environments. Always do something like this. The file is not there, because if you do a trivial mistakes, and this is common, I don't know, you have a typo here. You have student data. The file is not there. You want to see this fast, okay? When you test your program, you want to see this message fast, because you will know that there is some issue there. And the common mistakes here is search for typos here, okay? And secondly, go into the project folder and check if you have a student data.txt and check if you see extensions, okay? Don't hide the extensions because you will have .text. Okay, so let's say it's open. So what do we know? So here we follow the one line pattern, one value, one line, one line, one value pattern. So that file is created by you, or you should know at least the pattern. So what do we know? We know that the first value is what? Is the name of the student. So string name, student data, name. Okay, so now we got the name. We know that after the name, and always check your file, okay? Always go back to the file. So you know that here you have the name, and after that you have the age, and here you have the faculty. So int age, student data age. Now we know this is doing also the conversion. And after that, I have string faculty, student data faculty. Okay. And now I know that the next value, the next line is representing the number of grades. So student data, number of grades. Okay. And after that, we know, so at this point I can create the array. You see, that's why it's important to read the number of grades before the grades, because now I can create the array, number of grades. Okay. And now I can do this for int I at 0, I less than number of grades, I plus plus. And now I can read each grade. So student data, grades at index I. Okay, and now you read the grades. And here it is. So now we can build a student. So student, and here I will pass the name, age, faculty, grades, and number of grades. Okay, so here let's print the student name. This is the only thing that we print, but we can check this in the debugger and we can actually see if everything is okay. So, and don't forget to close the file. Okay, so this is very important. Student, close file. So build, rebuild. Okay, debug start without debugging. So I should, it didn't crash, which is great. I see the name of the student is John. So let's add a breakpoint here. Let's run this again. Debug start debugging. Let's start it again. Okay, and now let's check the data. So let's see. Name is John, age 23, faculty CA, grades is this array, and the first grade is 10. I can check it here in the watch one. Okay, and number of grades is 3. Okay, so which means everything was okay.
But if they are like on the same line, one after the other, do we have to make some changes in the file? Just by curiosity.
If what if the values are how the
on the same line, like with a space between them, just
like
or
this?
with a, yeah, or with a comma or something.
Yeah, it's much more difficult. Why? Because with a comma, when you read with input stream, you actually read the entire line. And after that, in memory, if you remember str_toc, the tokenizer, you can split this string, this big string by a comma. And after that, you take each value. But the lines of code that you need to write, it's much more bigger. And here you can do mistakes. So it's much more complex. Okay. Now, this is the simplest approach. Okay. And for example, if you get this for the exam or you want to do this for the project, I really recommend you to go for this because it's fast and generally you don't have time. Okay. Now, for the project, I think there was a requirement with CSV files or whatever, the team project. Yeah, then you have time to play with that. But if you want a fast solution, which is less prone to errors and to mistakes, this is it. Okay. Write everything on a single line. Now here you see we have multiple students. So can I create an array of students out of this file? Yes, but what do I need to know before reading the students' data? You need to know is the same logic as with the grades. Every time you have a value which varies in length, you have 2, 3, 0, n, always write that number there. So if you want to use this file to load data for multiple students and you load that into an array of students, then always write here on the first line the number of students. So you have 1, 2, 3, 4. So here I will write 4. And now the source code will change because now you see the first line is not the first student name, is the number of students. So right now I will read this and after that I will have a loop. And for each student, I will read with the previous pattern. Okay, so remember these two simple rules. Okay, one value, one line. And every time you have multiple lines, which may vary in number, write their number. Okay, so
like assigning to a static value the first value of the
this one here.
Yeah.
Yeah, you define in the source code, you define a variable here and you say a number of students. For example, you define it here. You read it. Okay. And after you read it, you can do a for. And you know that for each student, you do this. You see it? So now you can create an array of students because you know that you have 4 students or 5 or 6. And for each student, you have this pattern: name, age, faculty, number of grades, and the grades. And you just repeat this for this number of students. And that's why you need the number of students here, to know how many students you have here. It makes sense?
Yeah.
Okay. So use these simple rules and it will help you. You'll be okay. Okay. Now, input stream. So it looks cool. It's easy to be used, but it has an issue. Let me show you. And yeah, this is the way. It's not a bug. It's a feature. This is the way they implemented it. So the issue with input stream is that it's using space as a delimiter, as enter. So if you say here, John someone, okay, you see I have a space here. Let's go back to and run this in the debugger. So I will delete this, what we were talking here. I will put here a breakpoint. Let me show you what will happen. Start debugging. Okay, so you see I want to read the name. Okay, so the name in the file is John someone. So if I do F10, so step over, you see it got only John. And when it's trying to read age, it will actually get the other value, someone, and it's trying to convert it to age. Sometimes it will crash, sometimes it's not. And now if when it's trying to read the faculty, you see it's not able to read that anymore because everything now it's a mess. So when you use input stream, try not to use space, okay? Because it will always stop on this space, okay? It will always stop here. And the next time you'll try to read, we'll use this someone for the next value. So it's keeping that in memory and it's saying, hey, I already have it, here it is, but we need this as a single line. So in that case, when you know you have spaces there in your text files, you need to use the get line, okay? Not the input stream. So input stream is always vulnerable to space. And this is the way it will always work. So space is like enter. It's a default delimiter for input stream and you can't change that. So when you know you have spaces there, instead of using input stream, so for strings with space, then you say this student data get line, and now you see this get line is like something from the past. It needs a char asterisk. So here you need to define something like this, a buffer of 50 characters, whatever. And here you read into buffer, but not more than 50 characters because yeah, we are limited to 50 characters or whatever. And now it will read that into the buffer. And if you want to convert this to the name, remember, if you want to convert a char array into a string, you have the constructor. So name equals string of buffer. So let me show you. Debug, start debugging. Okay, so buffer is empty. You see 0xCCC. And now if I run it, here it is, John someone. Okay, and now name is John someone. Okay, now age, and now it will continue. So this will happen if you have space. Okay, so you can't use this anymore. Now, once you know this, watch out, and I can make you a promise. So for the exam, I will not ask you with space. Okay, so if I will ask you, you can say, hey, that's a joke, right? Because you said you will not ask us. So yeah, but don't forget input stream is stopping on space. Okay, and I will, if you, I don't know, if you get a requirement with text files, you can simplify it. So just go for without spaces. Okay, so I will not explicitly ask you use space because it will be a mix of get line, input stream, and at some point you can do a mistake here by mixing them. Okay, so I will not ask you that, trust me, because we want to see if we know the basic stuff, not this kind of details. Okay, so this is where you have the space. Okay, this is the way you handle it, and is the same way if you want to read it from the console. But there you are using cin getLine. So if you want to read from the console a string with space, then you have cin getLine. Okay, here we read that from a file. Okay, so this is how you read from and you write into text files. Okay, so writing, it's very simple. It's like printing at the console. Now reading from a text file, especially when you want to load data from that text file, always try to simplify it. Okay, don't try to make it pretty, because you will work a lot to parse those strings. So let's end the discussion with binary files. And for binary files, this is what you already know from C. I will just show you the equivalent. So binary files. Okay, and when you write into a binary file, never use the output stream, because the output stream will always convert. So never use this. This will always convert all the data into strings. Okay, so here we have a binary file. Let's see where it was. Here, my data. So let's take this file. Now, we know that when you open a file for writing, if the file is not there, it will be created. But again, you need to check. This is a very good pattern or behavior. Always check. So is open. So if the file is open, now never use this. And let me show you how you write different primitive data types. So here you have int VB equals 10, right? So if by mistake I will use output stream.
When you wrote earlier and you said that the text file, that the second IIS was AAPP because we wanted to write at the end, here this binary, what does it mean?
Binary means that this file should be interpreted at binary level. So remember, like in C, all the files are text files by default. Okay, and when you want to use them at binary level, so, and you will see this in the next minutes, then you need the iOS binary, because you want to tell to the system, hey, when you write an integer there, I don't want to write the value as a string. I don't want to write 10, 1, 0. I want to write it in binary, which means 4 bytes, 0, 0, 0, and so on. Okay, so this is the difference.
Yeah, and how do we show that we want to concatenate to write?
Again, iOS, append, or trunc. Trunc is by default. So if you want to run this many times and add data into my data bin, again, you use append. Okay, but for binary files, this is mandatory, the iOS binary, and again, also for reading, because otherwise it will be interpreted as a text. So it will try to convert by default all the bytes into ASCII codes. But in binary, an integer requires 4 bytes, right? That's the size of it. So if you use the output stream by mistake, let me show you. VB, and let's close the file here. Output binary file, close. So if I will run this, debug star without debugging, okay, nothing interesting is at the console because we didn't done anything. But if I go here at my data bin and check the size, you see it has 2 bytes. Yeah, but wait a minute. So why has, let me show you okay, so it has 2 bytes. An integer in binary has 4 bytes, right? So why do we have 2 bytes? And if you open this with Notepad or whatever, yeah, let's use Notepad++, then you see 1, 0. Yeah, but 1, 0, this 10, so if I open the calculator and if I go to the programmer perspective, an integer with the value 10 in binary, it means 4 bytes and it has 1, 0, 1, 0. And the ASCII code for 10, we don't have a printable character. So when you write numbers as strings, this is the string representation of the number. And this is a mistake for a binary file. We want to store the number as binary. So don't write, don't use this one, okay? Never use this one. Okay, so here, let's say, is a mistake. So how do we write? And here is what you should remember from C. Remember in C, you had those fwrite, fread with a very complex list of arguments. You have the same here. So output binary file, write, and remember this is for output. So this one is only for writing. And here, the first argument this function needs is the address of the value that you want to store in a file as a char array. So this is the requirement. So how do I get the value, the address of this VB variable? Address of VB. Now they need to see this pointer. This is a pointer to an integer, but write needs to see this as a pointer to a char. Remember when we talked about pointers? A pointer to a char means if you do +1, it will jump only 1 byte. So that's why here you need to do this cast, char asterisk VB. So always, if this pointer is not a char asterisk pointer, you need to cast it. This is the requirement for write. And after that, this is how many bytes. And this is very similar with fwrite. So here, size of int or 4, but this is safer. So in this way, I will write the integer. So build, rebuild. And if I will run this now, start without debugging. Okay, so it ran. But if I will go back to the file, where is it? Here, and check the my data bin, you see it has 6 bytes. Why 6 bytes? Because we have the append. So the second time we executed this, it added the integer in binary as 4 bytes. So if I open this in Notepad, you see, this is what I see. And you will say, yeah, but where is the integer? Yeah, Notepad will try to see that as ASCII, but a 0 byte is not an ASCII, it's null. But if I open this, let's see, with HXD, so this is I can see in binary the files. And if I open this file in binary here, this is the 1, 0, these are the ASCII codes. And this is our integer in binary. 0A, this is 10 in binary, 0, 0, 0, 0, 0, 0. So I see it in hexa. Okay, so in binary, all the values here should be written as their binary representation. Don't use strings. Okay, so if I go back to the example, let's put here trunk, because I want to delete the previous content. So in this way, you write an integer. Now, how do you write a float? For example, float VB2 equals 20. So again, you have this, and here you have the address of VB2 and size of float. So this is the way you will write a float in binary. Now, how do you write a Boolean? So Boolean, bool, VB3 or VB bool equals true. Remember, this means 1 bit, but we know it's actually 1 byte. So again, you do this. Let's write this one. Output binary file, write. And here I will say the address of the variable that I want to write there. So VB bool. Okay. And the size of bool, which is 1. So a Boolean requires 1 byte. Bool. Okay, and if you forget to do the cast, again, the compiler is helping you, saying, hey, this is a pointer to a Boolean. I want to see this as a pointer to a char. So you need to do the cast. How do we write a char array? So char name equals John. Okay, so here, this is a pointer to a char. So watch out here what you write. Always think what that represents. So here you say write, and here, what's the address of John? Don't do this mistake. Don't write name, address of name, because now you get the address of the pointer. Remember, this is a pointer, and it will store the address of the first letter here, which is J. So how do you get that address? Name. Remember, the name of an array, it's the pointer to the first value. And here, you don't need to do the cast to char asterisk.
Like when it comes to the Boolean, wouldn't it like crash? Because I know that you can't show on the screen or in the file it as a true or false. You usually show it as an int in 1 or 0.
So true, what do you think? It's a char value. It's a numeric type on 1 byte. What do you think true will be? 0 or 1?
1.
1.
But sure.
Yeah.
Oh, okay.
So it will write a byte with the value 1. I will show you in the next minute in HXD. So for name, and let's see the name. For name here, don't pass only the name of this. So name. And now how many bytes? How many bytes do we want to store? John, and always store also \0 because that could be helpful when you read it back. So here I will say string length of name +1 or without \0, but I will always prefer \0. So let's see, build, rebuild. Let's close this because it's blocking the file. So debug start without debugging. Okay, the output is not important. But if I go here and open this again in HXD, let's see. What's this? This is the integer. You see it? 4 bytes, 0A00000. What's this? This is the float. Okay, and the float has 4 bytes, 00A0. It's stored in scientific format. What's this? This is the Boolean. You see it? 1 byte with 1. So if you store false, it will be 00. Now, what's this? This is John, and this is the \0 because I choose to write it. So you see, in a binary file, all the values come after the other one. And the only thing you need to know when you read this back is what their order. The first was an integer, and after that, this one was the float. This is the Boolean, and this is the string. And in order to finish it, let's imagine you want to read this back. What's the problem with strings? Strings, they have variable length, right? So this could be John. This could also be John someone. This could be Bob, or this could be any name. So when you read a string from a binary file, so let's suppose you are here in the file and you want to read this, what will be your question? The $1 million question. How many bytes does this name has in order to be able to read it? So, and this is what all the programming languages are doing. Java will do this and so on. So when you write here, when you write a string or a char array, so when you write a string or a char array into a binary file, always write its size before the value, because this will help you when you will read the value back from the binary file before the string or the value, before the value. So you do this here, int name size equals string length, and if you choose to write the \0, count that one also. So do that. Now you write the name size here. So again, the address of name size and size of int. Because now when you will read this back later, you know that before each string you have the size of it. You will read this, and after that you can read the char array. Okay, so in this way you can read this back easily, because otherwise you will not know how many chars that string has. Okay, and yeah, how do you write a string? let me show this. And with this, we cover all the data types that we have. So how do you write a string? Again, let's say faculty name, faculty size. Let's define it here. So string faculty equal CA. Okay, so faculty size will be faculty. Remember, this is an object size. And again, you might choose to write \0 again there. And now you write this. You do the same approach. So you write the faculty size here inside the file. And after that, you write the name itself. So output binary, right? Now, how do you get the char asterisk, the pointer to a string? I just show you. So you do this, faculty C string. Okay, so this will return a char asterisk. And again, it will ask you how many. Now, if you have the size, you just pass the size because that's actually the number of bytes. So you just pass it here. Okay, so this is actually multiply with size of char, but we know that size of char is 1, so it's the same. So build, rebuild. And if I will run this again, start without debugging, okay, and go to HXD, but I need to, here it is, it has been updated. You see, this is CA with \0 at the end, and this is the size of it, 5, which actually means 5 characters, including \0, okay? So this is the size of the faculty. Here is John, and this is size of John. Again, 5 characters with \0. So when you read this file, again, you know that here you have the size of the char array. You will read this, and after that, you know how many characters to read for name. So always store the size of the string before the value. And this is how Java is doing it, C# is doing it. All the languages are doing that, because otherwise you don't have any clue how many characters you have there. Okay, so this is writing to binary files. Now, reading from binary files will use read, and it has a similar approaches as here.